Hello everyone, welcome to Networking Essentials, Unit 2, Protocol Layers and Reference Model. Because of a complex network environment, so we need to have an appropriate way to deal with networking issues. We will check our travel example first to know why we should have layering. After that, we have the Internet Protocol Stack, which contains 5 layers. And finally, we'll check operation in action. All right, that's it. Introduction. We have the fact networks are complex with many pieces, including these. Therefore, we have a question. Is there any hope of organizing structure of a network? Of course, it's yes. Let us talk about the example of air travel. We should use layers, and layers can split the whole task into several ones, including ticket, page, gates, runway, and routing. And therefore, we have the corresponding services: ticketing, page, gate, runway, and routing service. So of course, we should follow this model. Why layering? In fact, we should deal with a complex system. So we should rely on the concept of a layer to have a layer reference model. And with a layer reference model, then we can have several modules, and the modularization can ease maintenance, updating of a system. If we want to change some implementation of the layer, then this change will be transparent to the rest of the system. So for example, if we want to change something in the gate procedure in the case of air travel, then it won't affect the rest of the system. Well, is it layering harmful? Sometimes if we don't have the full consideration, it's yes. But if we have the full consideration, we can avoid the effect of harmful factors. Of course, we can apply layering in the complex system. And of course, we can apply layering to the Internet. Layering to the Internet, we will define the Internet Protocol Stack, including 5 layers: app layer, transport layer, network layer, link layer, and physical layer. If we have the app layer, then we have email, and so that we can have the corresponding protocol IMAP and SMTP. And web, we have the corresponding protocol of HTTP. And transport layer will care about process-to-process data transfer. So we can have an example of TCP and UDP. And we have a network layer. Network layer care about routing of datagram from the source to the destination. Therefore, we can have IP protocol and routing protocol. And link layer care about data transfer between neighboring network elements. And so that we can have Ethernet Wi-Fi that says IEEE L2.11. Finally, we have the physical layer. Physical layer care about the bits on the wire. With the Internet Protocol Stack, then we can use them to have the operation. Operation care about encapsulation and decapsulation. So now let us have the illustration. We have a message source, and then to the transport layer, adding header so that we have the segment. Adding segment to the data in the network layer so that we have the datagram. And adding header to the data so that we have frame in the link layer. And finally, we have the bits on the wire, and the wire to the router. Router extract to have message of network layer and message of network layer after processing further. Then we can put it to the destination. And to the destination, get from the bits on the wire, then we have an extraction to get frame. Then extract to have the datagram, extract to have the segment, and then to the application layer to have the messaging, so that we have the original messaging. Well, takeaways. In the short course, we have the reason for layering. Of course, if we have the concept of layer, then we can define Internet protocol stacks. Based on the protocol stack, we can have the operation in action, so that we know the operation of the Internet. Well, that's it. This is the today's course, Unit 2. That's it, and see you. Bye-bye. This is the end of this unit. Thank you for watching.